I am your host, Tony O'Neill, and today I am stoked to have Devon Sullivan with us, a true titan of mountain bike design and suspension engineering. Most recently, the Ride Dynamics Director at Intent Cycles. Devon is not only the lead engineer for Aaron Gwin, a 5-time World Cup champion and 8-time U.S. national champion, but also for Dakota Norton, a 2-time USA Cycling national champion, one of the brightest rising stars from the U.S. on the World Cup circuit. Designing multiple front suspensions, rear suspensions, and mountain bike frames, Devon is a wellspring of innovation. Buckle up as we dive deep into the world of cutting-edge bike design. Devon, I am super glad to have you joining us today.
Thank you. Likewise.
Awesome. You told me in the past about you had a pretty unique start into the engineering and design world of mountain biking as a professional in Whistler. Can you share with the listeners how all this really began for you?
Yeah. Hopefully some younger folks can find inspiration in that a little bit. I guess before that was kind of a typical upbringing as a bit of a shop rat, doing wrenching and mechanic stuff. So that was through middle school, high school. And then partway through first semester of college, I dropped out to move to Whistler to race professionally. And that was 24 years ago when there wasn't a whole lot of money in it. So it was definitely a passion project. As that was sort of starting to take off with some sponsorships and things like that, I ended up with a pretty severe injury. So filming a video with some younger rising stars, Jeff Golovich and some of those guys, Thomas Vanderham, which I realize now is a generation back. At the time, they were pretty young. We were filming and something went wrong. I broke my neck and there was a C2-3 full rupture of the disc. So at the time, there wasn't a lot of knowledge about spinal cord rehab. You know, now people like Brooke McDonald and some of those guys have made incredible recoveries. At the time, they just said, you know, you're in a wheelchair for an amount of time. So that was quite the reality check to get, you know, as a 20-year-old. That was rough. So that was the catalyst for me to go back to school for engineering. And while I was applying and enrolling and doing all that, there was just a long road to recovery, about a year or so, relearning motor skills, regaining strength, walking, all of that fine dexterity and things like that. So by the time I entered college, I was good to go, but it was a close call for sure.
That is some significant trauma that you went through. You mentioned that the amount of rehabilitation that you went through took almost a year. When did you realize, or when did you know you would be okay? And how long did it take until you actually knew the ramifications of what actually had happened to you?
It wasn't really a light switch. It was kind of a gradual thing where, I didn't plan on ever having that level of youth superhero mentality come back. But I always kind of figured after a few months, nerves start to heal, muscles start to fire. You start that really slow process. So it's kind of just a gradual, acknowledgement.
Were you at home during this period, or were you in the hospital? Where were you? What did the situation look like for that year?
Yeah, there's a lot of time spent in Canadian hospitals.
Okay.
And so, as a U.S. citizen, that was a bit different, a bit scary. They did take care of things, but the deficit there was all the follow-up. Coming back to the States as a U.S. citizen and having a lot of the trauma and injury be treated from another country, there was sort of a disconnect in the rehabilitation versus the initial doctors. So in hindsight, it would have been nice to either stay put and finish out the rehab or come back to the States right away. But at the time, when I first got hurt, I thought maybe I can fight this. Maybe I can keep living here. British Columbia is a wonderful place to live, right? So it's kind of a gradual acceptance process. And by the time I was in college, not many people knew about the injury. I didn't really display any signs of that. So.
Did you always know that you were going to go to school to become an engineer? Or is this something that developed during this rehabilitation stage that you were in?
It was the latter. Yeah, I was definitely inspired while living in Canada, just befriending some of the engineers at those companies up there and realizing like, wow, that's a pretty cool career. And these guys are out there riding their bikes. They don't have to put their health on the line. They can ride at a reasonable pace and stuff like that. So I kind of had that in my mind before the injury. That was some of my riding friends. And then when that happened, it was a given. It was pretty obvious, like, go to school for engineering. I can get involved in the bike design in some aspect.
That's a really good point that you bring up, that ability to still be involved and ride at a pace that, my understanding, or at least my experience, I don't have anywhere near the experience that you have or the people that you've helped. But what I do know is downhill racing, you're talking tenths of seconds, right? Like that is the difference between a winner, first place, and a second place. And so every pedal stroke, every turn, this better than anybody else, right? This is every single millisecond counts. And if you don't have to worry about the milliseconds, it's a very, very different experience going down a downhill course.
Yeah. And the evolution now, guys like Aaron and Dakota, what they're doing it blows my mind compared to when I was racing back then. It was kind of at the tail end of the Sean Palmer era and some of those guys, Missy Giove. There's a lot of just hanging on. It just went really fast and you hang on. And now, like you said, it's a matter of tenths. And it's such a impressive evolution to have watched that happen.
They and you are incredible athletes. I didn't realize it until I actually raced in the Powerade series at Snowshoe, how much physical strength and endurance you need. What's a typical time that these individuals or you guys were on the course for during one single run?
Fort Williams, one of the longest, at about 5. And then I think some of the shortest courses are about 3 minutes. So I think that would be categorized as maybe anaerobic. I'm not totally sure, but it's all out for a couple minutes for sure.
Yeah, it's the best way I could describe to anyone who's listening right now is it is running the fastest you can put yourself. It's at the highest BPM, full on, for the entire duration of the race. It is so spectacular and difficult and challenging. It's like nothing I've ever experienced before. And that's, I was a cross country racer, so I was doing long races, but not at that level for 5 minutes, 6 minutes long. So it was an amazing experience that I had.
That's why the conditioning has evolved too. And to give credit to those guys, I think they've replaced beer drinking with days at the gym. There's been a bit of an evolution there with taking it pretty seriously. It seems like motocross went through that before my time, but yeah, it's an evolution. It's pretty cool.
And that was my biggest surprise. When I raced the downhill series at Snowshoe, this is probably 15 years ago. My envision is these athletes are just drinking Mountain Dew on the chairlifts going up and just coasting their way down. And that is the exact opposite of what actually is going on out there. And so the level, like you said, and what they're racing at, I'm curious, were you ever involved or seen how they physically train? Are they using weights? Is it core? Is it yoga? Is it meditation? What athletes at this level, what are they actually doing to prepare for the series?
Everyone's got a bit different style. There's a lot of trainers involved now. So it sort of depends on which trainer they select. And Intense Factory Racing works with a guy named Todd, who's excellent. And, Aaron has his regimen as well, because he might as well be a coach at this point. He's so knowledgeable. So, and then Joe Breeden, one of our other guys, I'm not sure who he's training with, but he's surrounded by a number of World Cup athletes. So I think when they're at the gym, it's a pretty serious session, probably.
I can only imagine. Okay, from the engineering perspective, what's some of the unique challenges you face when you're doing the engineering for these elite athletes like Aaron and Dakota?
Yeah, that one's tough because at some point you kind of need to bifurcate the product into consumer and race. And sometimes you don't get that opportunity. So you design it for the racers, knowing that the rest of us can still ride it plenty, and not have any complaints. So the approach that I like to take is making sure that the elite guys are happy. And that's because there's nuances that, you and I can't pick up on, whereas Aaron, it could make or break a race run. So I think if you design it to that expectation, the trickle down factor is built in.
Is there a difference between the front and the rear suspensions that you've designed for World Cup racers versus the rear suspension and front suspension for someone like me nowadays? It's a weekend enthusiast.
I would say manufactured differently. No, that era is mostly gone. There's still some unique, works type of stuff. In general, if you think about the physics of what's happening on the bike, they're putting more energy into the bike. So there needs to be more dissipation of that energy than what an average rider might need. So things like revalving or custom tunes, you hear about that stuff all the time. At its core, that's just a matter of dealing with that energy absorption and decelerating the bike so that the rider can still keep their momentum. So it's not necessarily like an entirely different shock all the time or a fork, but the way that the fork and shock behave is modified for sure.
What are the different data points that are measured, or what are the metrics that you look to acquire during this acquisition, the data acquisition?
I probably can't go into full detail on that one.
Okay.
Aaron and Dakota and Joe and I spend a lot of time on making sure that we do that well. And I think that's part of the magic of it, right? There's some metrics that are just universal, right? So there's something called dynamic ride height or dynamic sag. And so basically what that's capturing is how does the bike's suspension averaging out throughout a run? So it's pretty common, in a bike shop to set up the suspension on the showroom floor, they call it, or the parking lot. But the average of how that bike is suspended throughout its run, meaning like the height of the fork, the height of the shock, and the balance of the two, that's a pretty common metric that's, I would say, one of the most critical. What that means is if a rider has got the bike too high or too low, it's not really cornering correctly, or it's too deep into the travel to absorb a bump correctly, or conversely, if it's too high in the travel, it won't track. So a lot of that stuff is used universally now, and that aspect isn't really a secret anymore. The data acquisition is pretty much used across the board for that, and that's a lot of initial setup on a bike. And then some of the nuances depend on the rider and the team and all that stuff that we come to agreement as a team. Like, hey, is the braking more important on this track, or the pedaling, which is, pretty uncommon, but those are all metrics that have to be evaluated each race.
Going back to when you were in school to be an engineer, did you know specifically that you wanted to focus on suspension and frame geometry because you are one of the most specialized engineers that exist? You and I've talked about it. There's a handful of people that understand suspension on mountain bikes like you in the world.
Yeah. And in college, there might be programs now. There wasn't when I was in school. It was the mechanical engineering program. And so it was either study physics or study mechanical engineering. And to be honest, after school, it was a bit of a wash. It's more how you interpret and problem solve. And I've worked at Fox with some incredible guys that had physics backgrounds, and then conversely, some guys that were engineering. So I think more of it is sort of how you problem solve and how you analyze things that can be improved on. And suspension wasn't a target for me. It was not even my first choice. It was just about 2 or 3 years out of college, I was contacted by Cane Creek, and they were sort of starting off with suspension at the time. It was pretty new, and I helped take some of their first products into market. And so, to be honest, they could have been headsets. At the time, there was a guy working there who knew headsets inside and out. So I took on suspension.
Okay. And you may be able to comment on this or not, but when I think of some of the original rear suspensions, right, you had the double barrel by Cane Creek. Is that a product that you were involved with, or was that already there in existence when you got there, or how did that come to be?
Yeah, I was involved with that, and then designed the first air shock for them. The hydraulics for those shocks were actually a partnership with Öhlins. So there's some pretty cool legacy going on there. They had scaled down those first shocks to work with FSAE cars, I believe it's called, the college senior project. So they had worked with Öhlins and already had a lot of valving figured out and hydraulics. And, and I was drinking from a fire hose from some legends, right, working directly with Öhlins. So that was pretty cool. And I learned a lot from that job. That was neat.
Okay, to recap, the mechanical engineering degree from the educational standpoint was about problem solving. There wasn't a specific program that then led you down this path of hydrodynamics, suspension, all these components of designing an actual suspension.
Correct. Yeah. Our program was pretty broad. I think most mechanical engineering programs are. So most students, I think, gravitate towards whether it's machine design or mathematics or whatever it is. And I really enjoyed dynamics. And that was one of our classes. It was a core class for engineers. And probably shouldn't admit it, but I failed it the first time. I was pretty busy with, being a college kid. And so the second time around, I just loved it. It was really cool, all the motion. And, there's these textbook things that everyone learns. Like there's like a fly on the end of a helicopter propeller and it's spinning around in space. And what's the relative motion for those objects and all that stuff really was intriguing to me. And some people really glom onto structures and material science and all that stuff. And it just wasn't for me. So I think I got really lucky that I got a chance with King Creek.
When you have a new design or a concept for a suspension or a frame, how many individuals are actually involved in the design process?
I think typically it starts with identifying a customer need, which is kind of a product manager, sales, marketing hybrid situation where, like what is something that can be better on the bike? That's considered a need. And so you start there and then you sort of lay out a number of ways to approach that within your scope. So, if you and I were designing pedals, we might say people are slipping off the pedal. How do we tackle that as a problem? And it's important to go through it that way instead of, it's really easy to get excited about an idea that you might have and give it a home. And I've been guilty of that as well because, a lot of engineers have ideas floating around in their brain, but it doesn't always answer a need. And so the company's job is to help facilitate that into a product. And then once that's kind of green lighted, there's a lot of fun sort of breadboard, they call it, which is real rough concepts to see if an idea is worth pursuing or not. And then the prototype phase, usually a couple different ideas. And then you hone in on something that's the final idea and you start getting that ready for mass production, which is a big part of the project. You work with suppliers, you work with the sales team to make sure they're getting what they want. And then, at the end, marketing hopefully is the team that gets real excited about what you've come up with. So it's a pretty big process from the very beginning till when it's actually for sale.
During this process, Devon, which individuals at times don't always see eye to eye? And there's kind of a push-pull, a give-get scenario when designing a new product like this.
It's almost always an easy one to pick on industrial design versus us, the engineering team, because, the engineer, like on a frame, for example, wants it to work. And if that's all it is, then it won't sell. So it has to look good also. And conversely, if it really looks good, it might be dangerous. It might not work. Who knows? And so, that can be done to the nth degree, even on like the knob of a shock absorber where you adjust the damping. Like, how does it feel? How does it turn? How does it click? Is there dexterity to it? Is there any tactile feedback? Is there audible feedback? All those things. So yeah, there's a lot of that. And I've been part of companies where that's in-house and where it's contracted, and pros and cons to each method. But yeah, there's always that part. And then I think sales too, there's usually an aggressive target, like sell this product for X dollars. And it's pretty easy to get carried away during the design and say, like, here's your product. It costs twice as much as what you guys wanted.
What's the frequency in which that happens?
For me, I've been guilty of it almost every time because, I want the best stuff. And it doesn't always mean that that's the right approach, but it usually starts there as just like pie in the sky. Here's the coolest thing we could come up with. And then you got to rein it in a little bit, right?
I think that goes across many things in life, right? It's if you go to build a home and you design it and your architect thinks, hey, the home is going to cost X amount to build. And then you go to the builder and the builder's like, you're...
Yeah.
So I'm sure this happens any kind of design with products or things that people are passionate about, this happens. So I can understand that, and something I'm guilty of myself. Is there ever a product or a suspension that is designed specifically for the racer that will actually never go into the mass market?
Yeah, definitely. I think some of the products, suspension and frame, I can't totally speak to something like tires maybe, but on those parts of the bike that I've been involved with, in general, things need to be overbuilt and a lot stiffer. And so what that means is maybe it's a heavier product than what the consumer needs. It's maybe not as comfortable. There's the age-old saying, like, what is it? Fast isn't comfortable, something like that. I forget the actual terminology, but it's really accurate, actually. Is, if Aaron was to give you his bike and he weighs the same as you, you would think the bike is not very good. And in reality, it's just catered to what he's able to do with that bike and that the absorption that it needs to be able to tolerate. So yeah, I'd say those things are definitely different.
Now, specifically to downhill World Cup level racing bikes, is it similar to where a cross-country racer, someone who races endurance, that a term called weight, there's a website where people really focus on every gram. How do we make this bike as light as humanly possible? Is that similar in downhill mountain bike frames or bike builds, or is that something that is typically thought about as an afterthought?
There's a limit to where people care about it. Yeah, and I've designed suspension for World Cup XC as well. Schurter and I have worked closely. He's a legend for Scott bicycles.
Legend.
Yeah, so I've set up his bike as well and designed products for him, and he does care about the grams because it's a matter of wattage, right? He's dragging around extra weight. The downhill guys, there's a limitation where the sprung mass starts to deter from the performance of the bike. So what I mean is, if you think of, like a tiny truck bouncing down a rough road, it doesn't have a lot of sprung mass to keep grip on the road. If you have a big, heavy, like dump truck going down the street, it doesn't really bounce around as much. And so there's a fine line between those two things with downhill, where they're not pulling that weight as a matter of like wattage with the pedals and the cranks, but just because of the mass and the inertia to accelerate, there is a point of diminishing returns where you get to say 42, 43, 44 pounds and the bike starts to actually slow down, even though it has really good grip on paper. So there is a point where downhillers do care, and it does matter a lot.
I drive a Land Cruiser, and it's a big SUV. It's heavy. And my wife drives a 4x4 also, but it's called a Jimny. And it's like this really compact, cute. It's a very capable 4x4. But the ride quality going down the roads where we live is the heavier Land Cruiser that I drive is definitely more comfortable than her Jimny, which is, again, super capable, super cool car. But it's like almost like being in a Cadillac compared to hers, where maybe it's like the off-road Porsche or something like that.
Yeah, you've probably seen that evolution. We've all kind of watched, some of the articles on Pink Bike or whatnot, where even enduro bikes now weigh what a downhill bike used to be thought of as, a good weight. And so it's interesting to watch that evolution, because enduro, I think, started out with the cross-country mentality, right? You're pedaling the bike. It's got to be as light as possible. And now those things are 35 pounds or more. So yeah, that's evolved.
The evolution. Tell us what other parts of the bicycle have you been involved with besides the rear and front suspensions?
So at Intense is designing the bike as a whole. And just like, Trek or Specialized or anyone else, what that really means is the frame. Mm-hmm. So a lot of the parts are sourced, even the suspension. The frame is sort of the guts of the bike, and it's what interacts with the suspension most directly. So do the wheels, so do the brakes, so does everything else. But the suspension and the frame really have like a one-to-one dependency on each other. So that part has been pretty cool, having done suspension for 15 years, working on the frame. And at RockShox, I did some other parts that were not part of the frame, but they were lockouts.
Okay.
And so that's an interesting thing for XC racing, where it's just a fun kind of physics challenge. You've got this thing designed to move, and you have a certain amount of ergonomic input, right? So your thumb or twisting your hand or pushing on a lever, whatever that may be, that's your input signal. And then the suspension needs to turn off in a blink of an eye. And so that's been pretty cool too, just because obviously electronics are trickling in and they've got their place to do that job as well. But doing it mechanically is tough because you're trying to take oil that's meant to just move incompressibly for the most part and stop that movement with, the touch of a button or your finger. So that's been pretty interesting to be part of that too.
You're involved in so many aspects, working directly with the Elite team, the frame, the suspension, in your past, obviously working with different components of the bikes. When you think about all these different areas that you operate in, which area do you wish you had more time to work with? Which is an area that you feel like is maybe underserved right now in this realm of elite mountain bike engineering and design?
I honestly wish I knew more material science because of tires. I think, everything starts at the tire, and they're often overlooked until you have a sit down with an elite rider. And that is the single component that's holding them up. And so if the tire doesn't work correctly, for example, if there's too much transmission through the carcass of the tire, then the suspension gets that feedback, transmits it to the handlebar transmits it through the grip transmits it into your hands, and then it's just this domino effect. So I think a lot of those guys at the tire companies are probably wizards of rubber engineering and all that material science, and that's just something I've never really learned, and it'd be cool to sit down with one of those guys and kind of geek out a little bit.
Are the elite racers racing on like a stand sealant, or are they using tubes, or they have foam? What's inside their tires that they're racing on?
I don't think there's one single answer for all the riders. A lot of the guys on intense choose to not have inserts, and instead of that, they run a carbon rim that can deal with the impacts without bending and then losing air pressure, which is obviously game over at that point. Some riders choose to run combinations of really stiff wheels with a cross-country insert, and then that kind of gives the tire some protection. There's a million different options. I think maybe some of it's personal preference with the riders. Some of those inserts even affect the feel of the tire. And I've been part of those conversations where, your suspension feels amazing, right? And we didn't do anything. It's not the fork didn't change, the shock didn't change. It's just the wheel and the tire with that insert are.
When you say insert, is this a tube, or is this foam, or is this a certain type of sealant? What specifically are you talking about?
I don't think anyone really uses an inner tube anymore. Most of these inserts, when you hear that term, it's kind of carried from moto technology, like the enduro motorcycle racing, where they're 250 pound motorcycles hitting rocks. So you need a ton of pressure in the tire to avoid flatting. So these inserts called mousse were designed a long time ago, and it's kind of a piece of foam that goes in there and it keeps the tire from damaging the wheel. And a byproduct of that is you can run lower pressure, you get more grip that way. On a bicycle, the downsides are obvious. You've got a heavier rotational inertia to deal with then. So there's kind of a trade-off. The wheel won't spool up as quickly, right? It won't accelerate as fast because there's more material there. But then you can kind of hit rocks a little bit harder. So some guys like that. It's a very personal thing.
What is the range of pressure in their tires are they actually racing on?
I think there's a pretty narrow window. Most guys don't get below 21 or 23 with some of the real small guys. The bigger dudes are around 30, 33. And that range is dependent on everything we're talking about. And then, the flip side to that is if you've got a lighter guy with very low pressure, his suspension will respond differently. So you can't take a 200 pound athlete and a 150 pound guy and say, here's your equivalent setups. You can't just take the spring rate or the air out of the shock and say, well, I did the math, you're X% lighter. So here's your setup, because the tire has also changed. So it's, it's kind of more of an organic, bigger picture approach now, instead of just like you weigh a certain amount, so here's your spring rate. It's evolved beyond that, where the tire, the rim, the handlebar, a lot of that stuff is all part of it. The frame obviously is a big one as well. Composite carbon frames, they inherently damp. That's their job, is those fibers can damp things. And so aircraft are going that way, is what I've been told. I don't know a whole lot about that industry, but a lot of metals are being replaced with composites because of that, because an airplane has quite a bit of high frequency vibrations. And so if your frame isn't carbon, isn't composite, say it's aluminum, right? Mm-hmm. Aluminum is inherently pretty stiff. So how do you take away that stiffness with a vibration mindset, but not just make the thing a wet noodle and just flexing all over the place? So that balance is tricky.
Where do you think the most opportunity exists right now from a mountain bike perspective? Is it the suspension? Is it the frame? Is it the electronics? Where do you see the most underserved area right now where the technology is going to advance?
For the everyday rider, I guess. I think for most of us, the expectation of how the frame works and the components hold up. So I guess that's kind of a two-part answer, but I think the frames are all held to a higher standard now than in the days of just a single pivot, and the shock had one adjuster. I think the average consumer is much more educated, and so that expectation has grown a lot. And then on the flip side, they also want the components to not really wear out. I don't know if the demand for electronics supersedes that. I think in my opinion, from what I've observed, people would rather have a component that lasts a really long time and holds up that sort of performance characteristic as long as possible, because the bikes are so expensive now. So I think that's maybe where things will be going, where there aren't really bad bikes anymore. They all work really well, and the components last a lot longer, than the old days of the XC bikes kind of just crumbling if you crashed on them once or something like that. So I think that might be where things are going based on a lot of feedback from consumers. I think for racers, it's a whole different ballgame, right? Those bikes, they don't need to hold up to those standards of being sold to an end user that expects 10 years out of the bike or something like that. They're very dedicated to do the job.
Spending most of my life in Indianapolis. IndyCar racing is, it's in your blood if you live there or if you're from there. And these cars, literally, the clutch, one race, right? Tires, yeah. How many sets of tires they go through in a single race. On a World Cup downhill bike, is there certain components that it's one run or certain components that's one race? Which are the ones these elite level athletes go through on a consistent basis?
Tires are definitely the given. That's the easy one. They don't want to have any of those lugs tearing or anything like that for the race run. Because they don't wear out a tire the way that we do. The lugs literally tear off. And so that's something they don't want to mess around with. I would say the front suspension, it's not really a matter of it needing repair, but having a freshly serviced front fork makes your hands feel better. There's just no arguing that, right? It's got fresh oil in it. Everything is moving really well. Nothing has sat and kind of gotten dry or anything. So the front suspension is, there's the mechanics at these races are just working their ass off. It's a rough job. So they're always running around trying to get that done. But also you don't want to change the bike too much, right? So, and slowly yielding during qualification and practice. And then you replace it with something fresh and it feels totally different and it throws you off. So it's kind of a fine balance there.
How many runs until they service either the suspensions on one of their bikes?
I think the top guys are every other day, roughly, at a race. So, they'll get a handful of runs on it.
Okay.
It's not every single run. Suspensions come a long way. The shocks actually don't typically get that treatment because they're part of the system, which is the frame. So they're a leveraged mechanism, right? So meaning 8 inches of wheel travel usually correlates to a few inches of shock travel. And so that leveraging effect makes it a little bit less sensitive in your feet, as opposed to a fork. Every inch that the fork moves, it's just 1-to-1, right? And so a lot of those shocks, they can make it through a whole race event and they're fine.
Now, someone who's going to go to engineering school, they write to us and they talk about, we really want to get into the cycling industry. If you were talking to someone who is either choosing a school right now where they're going to do their engineering degree or a program, if you could give them a little bit of guidance on their path, what would you share with them?
Yeah, I'd say for students that are currently, in college or university, for example, it's a matter of kind of networking your skills. So at that age, if your skill is racing, then, use that to build a resume of results and show the industry that you're really integrated to that. If your passion is, say, fluid dynamics, the stuff that I was involved in, you can get really a head start on that by doing internships or things like that, where you reach out to these companies and try to do any sort of projects that you can, whether it's through school or just traditional internships. And I think that jumpstart on realizing and recognizing what you're good at and what you can contribute is a good way to approach it. I got lucky in a sense with, my background and combination, but I think just like where you and I are in our careers now, networking is critical. So if you're young and you've got that passion and whatever that skill is, try to network that specific skill. That would be my advice.
Would you suggest going to a school that is renowned for cycling, like Marion University in Indianapolis, or is it more about being involved in the sport itself?
Yeah, I think that's what I meant with the racing. Like, for example, if that's what you're really good at and you love the industry, and then you want to go to, say, Durango or one of those schools that's really well known for their race program, that's a great way to take your degree and combine it with what you did during those 4 years. If you're really interested in fluid dynamics, like I mentioned, then there's probably other colleges that have much more involvement with some of that stuff, whether it's aerospace or any other industry. It's going to show whatever company like SRAM or anything else that while you were learning that, you were also involved with it hands-on. It doesn't have to be a bike job, but that's your passion, that's your skill. If you just love fluid dynamics, when you graduate, you've got a jump start and you're like, here's what I can offer the company. And then you enter that role, hopefully with something to bring to the table, because the passion's great, the excitement's great, but we all have that. So it's like finding your niche, kind of what is it that can you bring to the table? Do you have really cool projects you worked on with rubber and, you have something to offer for Maxis, perhaps, Kenda, or whatever it is. So yeah, I think carving out your spot is something that I would recommend.
These are really good points, starting early, trying to get the internship, and then obviously your network is the most valuable tool that you have that's going to help you get to where you want to be in your career. What are you most excited about in life right now?
I mean, I love watching these guys put down results. That's pretty cool. That goes back to working with Nino Schurter, and before him, some other guys. I worked with Craig Menard and Steve Peat, who are some legends. And just being at the races with them, that was maybe 10 or 15 years ago, and seeing the product that I designed firsthand win a race, that's pretty cool. And getting to talk to those guys, and they're always appreciative of it. There's not really a barrier or a barricade. It sometimes was intimidating earlier in my career because, what if you screw up? What if this product breaks or something like that? And I did that to Aaron. Literally, a shock blew up on him and in a practice run, and it was a prototype and didn't hold it against me. He's a professional, so he knows that stuff happens. And I think that part of it is really neat. I like that a lot. Just being able to see people enjoy your product for what it was intended to.
Do you think that World Cup downhill mountain bike racing, is it in a growth period? Is it staying steady? Where is it on a decline? Where do you see it from your vantage point?
I think there's a lot going on this year with that because of the Red Bull change to Discovery with just how it's televised and how it's broadcast. And I know in our country it's different than, say, in the UK, where Joe Breeden watches some of his own races. And I don't think this country has really embraced the sport as much, as the mainstream sports. And so that's been tough. I think if the televised and the broadcasting steps up, then the sport is ready to also step up. But no matter how close we get to F1 with the athletes and the bikes, it doesn't matter if people aren't watching it, because then the dollars don't come in.
Yeah, so that's a good message to any brands that may see this. There's a great opportunity right now to be part of the streaming of these races, since there is a void right now.
It seems like it. Yeah, I'm not an expert at broadcast, but I know, God, the statistics behind, a college football game are staggering with the view numbers. And so if these guys could get that sort of publicity, essentially that's what it is, right? Then the sport would follow suit. And I think technology-wise, it's there. The athletes are ready for it. They're taking it very seriously. It's an elite sport now.
Looking back, what piece of advice would you give yourself at the very beginning of your career?
I think patience has been a tough one. Being involved in something that you care about, just, being able to separate from the product and put the customer's needs first. And sometimes you got to wait it out and see how things go and just be more patient and trust that process. That at these companies, there's a lot of people smarter than I and more experienced than me, and they've been through things. And so, it's hard to tell that to yourself when you're 20, kind of excited about everything. But yeah, that patience and trusting that process would be something I could have done better. And, maybe stuck around at certain companies longer, even just seeing the products improve over time on a life cycle that's slow, maybe slower than an engineer wants to stick around for, because they want to see something new and exciting come around. But a lot of guys I've looked up to in my career, they're very patient, they're humble, they trust the process, and eventually, they're happy with the outcome. It seems like a pretty common theme.
I think patience is a really good piece of advice. If we could all just take a step back. For everyone who's listening, be as kind as you possibly can to everyone you encounter. But even more importantly, be kinder to yourself.